Assalamu alaikum. This is Dr. Munder. This is the chapter one continue, and today we will talk about object analysis and design methodologies. Before we start, let's see what we're gonna talk about exactly in the lecture. So we will discuss the development life cycle and what's similarities between the software development life cycle and object analysis and design methodologies. We will discuss three object analysis and design methodologies, and we will identify the main characteristics of this methodology, the phases in this methodology, and what are the main symbols used in this methodology. We'll also show you some software called eDraw Max that can be used to draw a diagram using any methodologies. The first methodology, before we start the methodology, now object analysis and design, it is similar to any software development life cycle. It will include the requirement and design, development, testing, and implementation. Basically, it is contain what? It contain phases. Okay, it contain phases, and these phases are the main component that shows the development of the any software. So object analysis and design is not actually different from this. It contains phases. Okay, it shows basically some of the phases for each methodology, and we will see when we discuss some of these methodologies these phases. We'll not have the same exact phases, but we'll have some of these phases in the methodology. Now, if we have object analysis and design methodology, it's a good thing because what we have, we can reuse the code. So if you have a company, you will have low maintenance cost, okay, and you will have better quality and you have high productivity of the software because you are reusing the software. That's the good thing that we can benefit from object analysis and design methodology that we follow. Basically, we will use the UML diagram or symbols into drawing these diagrams in each methodology. This diagram will represent the system structure, system process flow, and the state of the system. We will discuss this in the next chapter, inshallah. Now, if you want to follow one of these methodology, you need to answer the question, and you can see this question in all these methodology that we will discuss later on. So what are the main object of the system? You have to identify the main objects and the classes in the system. You have also to specify the responsibility and relationship of all objects and their collaboration with other objects. That means you have to identify the relationship between objects and the classes, and also type of this relationship and the degree of the inheritance, the multiplicity, and so on. And also the state of each object over the time by performing a method or receiving a message and so on. So this is a kind of the main things, that question that you need to ask yourself when you follow any methodology or design any object analysis software. Now, the problem with having more than one methodology is that each methodology has its own symbols to draw the diagram, and we will see that this is the problem, that to remember which symbol to use when we draw these diagrams. So maybe you will mix up a little bit from all of them, which is not good. The diagram here shows the development of the UML and how other, for example, we have this methodology, Jim Bromwell, which is basically GMD, and we have Bush methodology, and we have other methodologies such as Jordan, Jackspon, and Partner Expert, RTF, Revision Task Force, and so on. And there's other methodologies start in the way, all the way. So we have a lot of methodologies. Some of them fragmentation, some of them unification, some of them standardization, some of them industrialization. It depends on how they, somehow the purpose of the methodology when they develop it. So this is just a history, shows diagram, shows the history of evolution of the methodology. The first methodology we'll talk about is called Boch methodology. Boch methodology is a very famous methodology, and you can find the diagram of this methodology in most of the software that used to draw diagrams. Now, uh, some people they use it actually to for the software development. It contains two phases, analysis and design phases for the system. It is a descriptive method. Okay, it does, okay, it explain what is the intent of the system definition, which is very good, but there's no guidelines. That's a problem. Okay, if there's no guideline, then you cannot develop or modify the design and the analysis of the system later on to be much better and better. Okay, so this is the good thing about Bootch methodology and the bad thing about it. Okay, the bad thing is just no guidelines. How this work? As usual, refer back to the question that we ask when we design any software system. Start with what? Class and object diagram. This class and object diagram is basically part of the analysis phase. Now, when you draw this diagram, you need to go back to the question and say, list all the possible classes and objects in the system. So you have to identify what are the main objects and the classes that included inside the system, and then you draw the diagram for these classes. So I say, okay, this is the classes and the objects that included in the system, and then you draw the ER diagram that shows these diagrams in the system. And you can also through the system development refine this diagram to be much better and better. Now, the symbols used in the diagram are basically can be depicted into a code. When the code is written, it can be depicted to the implementation directly, easy for you to implement that. And the good things that you can benefit from this advantage is that it is possible to fully document the code because we are depicting the symbol in the code. Now, the Bushmith models are contain three or four models, starting from a physical model, logical model, and static model, and dynamic model. The physical model is basically is about what? Is about the description of all the process and the model that will be in the system. So, for example, if you are implementing a system for the college, you can say the system will include the student and the classes, and the process will be registration, withdraw, and so on. For the logical models, you have to describe what? The classes and the object in the model. So you care there, here you care about the process and models, okay? But here you have to discuss what? The classes and object including in the model. So you say this model will include okay, this model will include, so you say this is the system boundary, this is the system boundary, and you identify the objects inside the system and the classes inside the system that will be included in the system. So in this case, you focus what? You focus on the problem domain. Anything outside the system is not actually related to the system, and that's define what? And describe the problem domain or the abstract of the system. The static model, okay, the static model is more detailed, so you have to go and say, okay, how these classes and model will be what will be related in the system. So this one will be related to this class, this will be related to this class, and this will be related to this class. It's called the static model. Dynamic model is including shows every part in the system, which include the class, the objects, and all other methods that can be included in the systems. Okay, this system will have to produce some good results. This system when the system work. If one of them is not necessarily, then we have to remove it from the system. Okay, it includes because we are producing the results, so we have to describe all the operation happen, all the scenarios that could happen in order to produce this output or this result. And these could be depicted somehow in a diagram. So when we do the implementation, it's easy for us to implement it using any programming languages. Now, these are the main four models that included in the Boch models. Boch diagrams are include many diagrams such as class diagram, object diagram, model diagram, state diagram, interaction diagram, process diagram, and more other diagrams as well. This is an example of the interaction diagram. For example, you have the first object or the objects inside the system here on the top, and what is the role of each object in the system, what time he will be this object will be active and have some rules inside the system. And you can show that the interaction between the objects by showing the message that sent between objects or the operation that performed when this object interact with the other objects. That is one sample diagram, which is called the interaction diagram. This diagram. Okay, so this is just a simple diagram, shows exactly the scenario and the process happen between interaction between objects inside the system. This is the Bush notation. It uses dashed cloud for the class diagram, and it used the continuous line for the object. If you wanna show the object, you can write the class diagram here, and underneath the class diagram we have the attribute and we have the operation. This is class details, that shows the class details. So you can put the class name here, what is the superclass for this class, what are the subclasses included in these classes. So we have what is the responsibility of the class and what or other collaborator or objects that collaborate with this class. This is a sample diagram, okay, that shows the Bush notation used to draw the class diagram, or shows the interaction between the system. You can see that it is this cloud dashed one is represent a class. So the class diagram will be here. These are the notation. I will show you the program, a famous program that used to draw diagrams. It's called eDraw Max. I have already downloaded the trial version. So if you want to know more, probably you can go to the online one, or you can download it or buy it if you want. That's a very good diagram. I can show you the screen now. It looks like this. This is the eDraw Max. When you go to file, you can see this is software development, and you can see here we have Booch object oriented. When you click on Booch here, you can see there's more than one diagram. Every diagram you create, it will be added here. So for example, you can create a new diagram, okay, Booch diagram, new one. You can see the symbols are here in the Bush diagram. If you want to know these symbols, you can go back to the slide and look at the meaning of each symbol, which is here. So this one, it means class of property. This is the class relationship. We know this is the class. This is for the data flow, if you want to send data flow, and all these symbols is already there. So if you want to draw a very simple diagram for the class, you can drag this one and put it here. You can change the class name. For example, let's say I want to say a class is called student, and the attribute for the student, for example, what SID, and then we have a name, for example, we have GPA, we have for example what major. This is enough. If you want to go for the operation, for example, okay, you can say withdraw, for example, courses. You can say attend the class, for example, attend class. You can say, for example, register a class, and any other method. Restriction, you can add, for example, restriction on this, saying it should be مثلا, for example, Omani resident student. must be Omani resident student, or must be Omani nationality student. Nationality, for example, student. You can change the size. You can change the size of the by here, and you can make it to include all the features. You can drag it somewhere if you want. You can drag the whole thing from here. Actually, drag. Don't forget to drag it from here, so you can move it anywhere. You can shadow. It's like Word. You can shadow select all the text and make the size smaller to include it inside if you want. Okay, you can extend it like this and try to make it the shape is much more relaxing one. Something like this is for drawing the relationship between classes. Okay, so if you want to draw another class, you can put it here. You can make it, for example, a class. Make it course, for example. You can add attribute for the course, like course ID, title of the course, and so on. Okay, the operation for the course, I'm not adding any operation, just this. For example, I can make a relationship here by drawing to this one, and I can specify the relationship and write something on it. I can add attribute or properties to the class right here, and you can add something to it. That's fine. And you can draw a complete one. Okay, you can change the colors. You can draw the lines connector here. You can add a text if you want. You can add a text, drag and drop, and you can write here, for example, student can what? For example, student can register, for example, register course, something like that. So basically, this is a class diagram shows. If you wanna know more about it, can a class, a card, which is basically shows the class card. Here you put the class name. Here you put the super class for this class. What are the subclass? For example, I can say here we have courses. Let's say class called courses, the major class course, the major this is the main class. What's the super class? Super class of this class is called, for example, specialization, okay. And the subclass, and from this class, for example, we can have math courses, and we can have IT courses, for example, and so on. And you can add the responsibility of this class, what are the main responsibility or operation that this class can do, and what other class collaborate with this class here. You can add a list as well. This is a class card. This is just a definition, like an ID for the class. You can add it, it's an optional for you. So this is how you use the eDraw Max. You can use it actually online. So if you open Google, for example, you can go online like this. I think there's online version of this program. You can search it, eDraw Max. I think there is an online version for it. Let's see if there's, yeah, I think this is the online one. Yeah, all online one. So you can have it online. You can get started. You don't have to download it. You can have, for example, a new one. If you click a new one, you can choose basic diagram, or you can use software development diagrams, and you can choose the Booch diagram or the data flow diagram or Jackson diagram, any diagram. You can add a new one if you want, or you can use from the samples. You need to create an account and use it online, or you can download the soft trial version and see if you like it, then you can continue on that. This is the eDraw Max, which use actually most of the methods. And these are the symbols, and these are the relationship meaning inside the diagram. Now, the second one is called code and Jordan methodology. It is include the same thing, include two phases, analysis and design, the same as Bush method. There's 5 steps in the analysis. Subject, which is basically, it is more detailed, okay? You draw the data diagram, the basic data diagram between the object, which include the object. Data flow diagram. Data flow diagram shows the how the process happen, or how the data flow from one object to another object. So you say, for example, a student give his ID to the registration object, for example, and the registration object will contact the for example the finance to check if the student is paid or not. It shows the flow of the process, or how the data is going in between the objects. The objects you have to identify. Now we identify the data flow diagram for the object. We have to identify the object classes and the class inheritance, so you can specify more details about the inheritance between classes. And then after that you can go for more detailed inheritance that show between classes, which is called the classification structure inside the structure. Or you can just draw a simple line connection that show that these class are associated, which is basically a composition structure called. And then you can identify the attributes. If you draw the class diagram, you put the class here, then you can identify the attributes in a separate step. And the last step is to identify the behavior or the operation of the class as well. These are the 5 steps. It just to specify uh, drawing the diagram in more specific steps than altogether. This is a good way actually. Now, for the design, it contain what? It contain also 4 steps. Now, these steps is already included in Bush methodology in a snapshot. Okay. For example, define the domain problem. So you have to identify the domain problem, what is inside the system, what is inside the system, and what is outside the system. So in this stage you identify the classes and object inside the system. And then the human interaction, you need all to consider the human interaction when you design the interface for each object. What is should be in this interface, what should be in this interface. So this is more like an interface that the user will use. You need to consider that what the classes need interface, what the class does not need interface, what the class is an abstract, what the class has different interface, and so on. And then task management, you identify some of the classes are really doing the task, okay, but this is a class. This class is doing the task through separate subclasses. So this class basically manage other classes in order to do the task, okay. And then if you specify the system-wide management for the classes, which class is managing other class, then you have to specify what? You have to specify the data management. We're talking about now data access method. Who can access the data, who cannot access the data from these classes. This class can have direct access to the database through this method, but other class cannot have access to the database anyway. So this is just a very short, simple 4 steps for the design phase in Jordan code and Jordan methodology. They have these symbols, okay. As you can see that the class is same as UML. The difference is that not sharp edge, it's more like a circular edge like this. And you put the class name here, and then the attribute, and then after that the operation that the attribute or the class can do. There's generalization and specialization is implemented like this one, and there's other symbols as well in the diagram. These are 2 samples. For example, here we have the data flow diagram for the ATM. It shows that we have a client, and we have the ATM, and we have the database, okay, because the steps is caring about the database. So the client first insert the card into the ATM. Then the second step, the ATM will request the bank account detail from the bank database and will return back this account in the third step to the ATM system. The ATM system then wait for the user to insert the PIN number. So the user will insert the PIN number as the 4th step, and it will validate the PIN number and get back to the user if the PIN number is wrong or not wrong. If the PIN number is wrong, is right and it's not wrong, then it will the user can withdraw the money as this number 6 can withdraw the money, and the bank will what will give him the account sorry will give the amount to the, so the seventh step will give the man, and also will notify what will notify the bank that the withdrawal happened to, in order to reduce his balance this amount. So this just exactly so what happened to the data and how it's flow from one object to another object. So we have three objects. We have the client, we have the item, we have the bank system, and the data flow from them and show what operation is happen and what's the state of the these data. Second example is the order process. When you provide your address to the any order process, it will go into verification validation process. So take the zip code, phone number, street address, and validate each one separately. Validate each one separately. So this is much better and detailed one. This is for the Jordan. Now, if you go to the program, the eDraw Max, I'm sure we will find if you want to draw a new diagram according to the Jordan and code, you can get new, and if you click on here, I think you will find it. Yes, you can find it here, and you can see the diagram is class diagram looks like this. This is the generalization and specification, and you can add the attribute. You can modify this one and say this is the student, and this is for class, and specify more. This is, for example, you can say this is for the major, and the major could be more specified IT, and it could be also math, for example. We have two things. You can delete this one if you don't want it, that's fine, and delete this line. Back this line will go back here, no need for it. So we have two classes. If you move this one here, that will come up to this part. Okay, remove this one, no need for it. So you can modify the class, or you can create a new one if you want, like this, a new, and add a new one, and then you can drag and drop a class like this and modify it, drag another class like this, and you can specify that these classes are generalization from this class. This one goes here, okay, this one here, and this one goes to this class and up a little bit. Yeah, it is a little bit tricky, so yeah, you can actually have to somehow control it. Yeah, and you can draw a simple line like this from this class to this class, and draw another line from this class to this class, and you can have like this. So it's become more like, you can draw any line you want, and the lines are already here, so you can choose any connection. You can add text, you can add shape if you want. You can draw a line like this and do something for it. uh, a lot of options. Okay, it is very flexible and powerful programs. Go out into that program and get used to it. It's much very good. You can use Visual, you can use iDraw online if you want. That should be fine. Rambus methodology is very simple one. It's contain three model: object, dynamic, and functional. The object is more about the structure of the system. Okay, the structure of the system. So you have to identify the classes and object. Okay, of one, and then you have to identify the attribute for each one object or classes, and then draw the relationship between them in one thing, a very simple thing. Okay, the relationship, you can specify the relationship and include the inheritance, is it multiplicity, the degree of the association, and so on. And you have described the structure of the system. It's more like a graphical interface structure, like a class diagram or object diagram. Dynamic model is about operations. What operations is happening in the system and how's the operation is going to happen. So you can have more than one scenario. Registration of the student. What are the steps for the registration? Student has to pay first, and then go to the supervisor, and the supervisor will agree on that, and then he go to the registration department and do the registration. So it specify more details into that, and it's similar to the red light. Okay, the red light is red and green. Okay, and green. Okay, and then after that it will be yellow. Okay, so yeah, red, green, yellow. So this is the state, the flow. So here you are stop. When you see this green, stop. When you see yellow, prepare or be ready, for example. And when it comes to green, you can say go. You can see that it specify the state of the object and also the flow of the data between objects. Okay, the behavior of the object, what happened to this object has become red and the state changed, and what's the response of the other object in if the state of another object change, or of an event happen, and so on. And this is can be replicated in a state diagram. We will learn how to draw the state diagram in the next chapter, inshallah. So this dynamic model is all about the operation and the state and the flow of the data. The last one is a functional model, and the focus of this one is on the data. What happened to the data through the system? Changed, not changed? What's the input of the system? And what's the output of the system? So what's going on and what's going out of the system? So three models: object model, looking about the structure; dynamic model, care about the operation; and the functional model is more like following what's happened to the data in or outside the system. This is sample implementation for notation for Rambo. So it is similar to the UML, a class name here and the attribute here and the operation here. This is so the structure of the, this is more like object model, so the structure of the system. Very simple and easy. Okay, this is a class notation. This is the dynamic model. It shows the state from idle to pumping to waiting to cancel, and how's the flow of the data and what operation is going on inside the system during the time, similar to the traffic light I explained in the previous slide. The last one is the functional models, care about the data. What happened to the data goes inside the system, store the transaction. The transaction goes to the transaction process. Transaction process will archive the transaction and save it in the transaction archive. So these are the models. So the object, dynamic, and functional model. Some diagram are considered objects, some diagram considered dynamic, some object diagram considered functional. These already included in the other models in different names and different phases and different steps. There's other methodology, a list of methodology. If you want to know more about them, you can try and go on and use them. But now more focus is on OMG and rational and UML as well. So UML now is a famous one. You can see the history from 99 to 91, 95, 94, and then now UML is more standards way to draw diagrams. This is also what we have learned. We describe the project life cycle phases, and we say that object analysis and design are not that big difference from the project life cycle. It contain phases that has to be, contain some steps. We explain three methodology: Boch, Code, Jordan, and Rambo. And these we explain them in not in too much detail, just a snapshot. We show some of the symbols that they use, some of the diagram they use, and we show you some of the software tools called eDraw Max that can be used to draw all these things. Now, it is a good thing to have more than one method, but the problem that if we have more than one method and each one has its own symbol, then we have difficulty to remember these things. And we said that the simplest method is round methodology. It is a very simple method. That's all for today, and I'll see you in the next lecture, inshallah. You have a good time.